So let's see where to go. There we are. Inserting into the Academy archive. Now, if I try to run this now, it's going to holler because I haven't created that Academy archive database, and that's why it's actually got the little squiggly there saying, hey, this doesn't exist yet. So before I can insert into it, I'm going to have to go create it. And one easy way to create it is to use another form of into, which is select into. So here I'm saying grab all the columns, select star, into a new table, Academy archive. Oops. So just some new table name. What am I selecting from? Academy, right? But because at this point I just want to create the table, I don't want to actually insert any data, I'll say where the Academy ID, whoops, there we go, is equal to 0, which I know there's no records there, right? So, in fact, what I can do is, let's comment this part out. Let's just do a select from Academy. And if I execute that part, it comes back with the schema, the columns that are there, the data types. So that's what I want. Now, I'm going to create a new table using that same select statement, using the into clause. That's going to not insert any rows, but look over here, refresh the tables. Yet another way of creating a table using the select into statement. Now that new table has been created, which is basically a copy of the Academy table, I can populate it by doing an insert into. So, and again, I can do just part of this statement to see what's going to be inserted. Looks like 3 rows are going to be inserted. So then I'll do the insert into. Oh, and it says, you know what? The ID is an auto increment. You can't specify a value for an identity insert. So I have 2 options here. One is to say, well, I just want the Academy, not the ID, but just the name. So I'm just going to select the name. And then if I do that, I have to specify the column list here. So here I'm matching up. Select this piece of data, put it in that piece of data. They happen to match. More times than not, they will match. They don't have to, but this is mapping the Academy name in here to the Academy, the source, which is that one. So now when I do this, so I'm ignoring the ID. Now the Academy archive has 3 records. The other option would have been to turn off the identity insert. So the problem now is, if I run that statement again, 3, 4, I ran it 4 times just now, it keeps adding records. So if I, it doesn't, because again, I ignore the ID. If I absolutely want to make sure that the ID that from the source matches the destination, what I have to do is go to the Academy archive, change the design, the schema, say, hey, you know what? Identity insert doesn't make sense because this is an archive table. It's copies of records. So let's go in here, and actually, it's not an identity. Is it? Let's take a look. Oh, let's see. It is. See, yes. So we're going to change that to no. Save that. Now I can go back to my original statement and say I want all columns. And before I do that, let's empty it out. So it's got 12 columns in there. Let's script as a delete. So we're just going to delete everything, no where clause. Now it's empty. Now we're going to go back and populate it with an exact copy. Let's close some of these windows. We don't need that one anymore, that one. So here we're going to copy Academy Archive, or copy the Academy table into Academy Archive. If we try to do it a second time, it's going to, well, it's going to do it, but it's going to copy all the same records. So let's go look. And indeed, 1, 2, 3, 1, 2, 3. So in order, if you're doing this kind of select into statement, you're either going to need to, not include the ID, or if you need the ID, make sure it's not, the destination is not an identity. All right. Real quick, in Access, there's similar functions. So in Access, if I want to do a select into, what I can do is say, hey, I want to create a new query. Maybe I'm going to use addresses, and my query type is going to be a make table query. So maybe I'm going to make a new addresses archive. If I look at the SQL, it's a select into. So Access has the same functionality. It's got all these little widgets and everything to bring it up to try to hide the SQL, but the SQL's very similar. All right. We mentioned that there's conditional restrictions, the where clause, which will reduce the amount of rows that we can use either in a select or an update. It's optional. When we use the where clause, there's all sorts of comparison operators we can use. You can use it with characters, strings or dates. These are some of the comparison operators that are available to us: equal to, greater than or equal to, less than or equal to, not equal to, which can be either the greater than less than sign or the exclamation mark equal sign. They both means not equal in SQL. Comparison operators. SQL accepts any valid expressions or formulas in computed columns. An alias is an alternate name given to a column in a table in any SQL statement to help with the readability. And a computed column, an alias, and date arithmetic can be used all together in a single query. So let's take a look at what that means. So let's go back to SQL. And I'm switching back and forth between Access and SQL, but just about everything I do can be done in either one. So here we have a select statement where we're pulling data from the Academy table, the Academy Archive table. What if I want to just get the ones where the ID is 3? So I can say where Academy what am I saying? Where Academy is equal to 3. What's that equal? What's that return? So just 2 records. We have 2 records where they're equal to 3. That's your where clause. What if I want to say, let's get rid of the top 1,000 because we'll just take them all. What if I wanted, instead of having to specify this whole thing, I could use an alias and call this AA. So up here, I can now use that alias AA to qualify these field names. Let's run that. So notice it ran fine. There's some squigglies. It doesn't like the fact that I'm still in the master database, but because we fully qualified, it's still running okay. I can't stand the squigglies, so we will switch to Smart Chart just to try to placate the squigglies. Nope, it's still okay. Well, it says invalid objects, but guess what? It runs just fine. But that's the alias. And again, because I don't want to so the other option was I could still fully qualify if I needed to fully qualify these. I could put that instead of the alias, and that's let's see, what did I do there? Smartchart.dbo.archive. Let's get rid of some of this stuff. This is actually too many There we go. Get rid of the alias for a second. There we go. So if I don't have the alias, I can fully qualify my column names. Let's see if we do the whole thing. Yeah, the whole thing works too. But no one wants to ever do that. Why would you ever have to do that? If there's more than one table, we'll talk about join some more later. But if I was joining another table, say the levels, I don't know, some other table, and that table had, a column that was the same as the archive table, then I need to differentiate those two if they had the same name, and I would do so either by fully qualifying it or more likely by using an alias. So then I could just say this is the Academy Archive, this is also Academy Archive, and then level might be just L. And then I can use the L as an alias for level and the AA as an alias for smart chart, blah, blah, blah. Let's put this whole thing in front of level. Let's just, for now, we're going to cross join this to make things simple. Where's level at? Level, level, level. Levels, excuse me. There we go. So nothing. No Academy ID equal 3. Let's put this. Thought we did. Did we delete something? Let's lose the cross join for a second. There we go. We have 2 records. Oh, you know why? I bet you this table's empty. Let's select it. Indeed, that's why we were getting 0, because 0 times anything is still 0. So when we cross-joined it with an empty table, we got empty result set. That's a good point. All right, let me close some of these windows. It's a problem with doing SQL. You can end up with a ton of windows. You're like, wait a minute, hold on. All right. All right, let's jump back to our slides for a second. So we talked about aliases. So computed columns, basically it's this idea where we say, hey, get rid of some of this stuff, use another select statement. Here I'm getting the Academy ID and also the Academy name. But what if I wanted them together, right? I could say Academy ID, concatenate it with a space, and then the Academy name. And we'll call that the, Academy key maybe. Let's see what that does. So it's saying, hey, you try to concatenate a string with an integer. Doesn't like that. So we're going to cast that ID, that integer, as a varchar of, say, I don't know, 2. Because it's, it's not going to be greater than 100. So now we've converted that ID to a string and concatenated it with a space, and then so this is a computed column, and we're going to call that whole column Academy key. So when we run this guy, look at this. There's our Academy ID. That's straight from the table. There's the Academy name. Now we have this computed column called Academy key, which is the ID converted to a string, 2 characters, that's why there's a space in front of it, plus a space behind it. And maybe what we'll do is we'll put, just something we can see a little bit better. So there we concatenate it with just greater than, less than, and then the name. That's a computed column with an alias. All right. When we're using arithmetic operators, the rule of precedent is, what order that computations are completed. Obviously, we do anything within a parenthesis first, then we do our power operations, then our multiplication and division, then any additions and subtractions. This is typically what we're used to. These are the arithmetic operators that are available to us. Probably the interesting one is the power, which is the caret, the one above the 6, shift 6, raise x to the power 3, something like that. This is an example of the product table where we can use a logical OR. So if we want to start selecting different rows, we can use an AND or an OR. These are some of the different results from your book. Let's actually bring that up if we can. So let's go back to Access for a second, and let's open the data. So let's see where we are. We want to go here. We want to go out to our iTech 315 folder. And we're looking for chapter 7. And we want the, which one is this in? I think this is in, let's try the sale company. And the slides have us looking at the what? Product table. There's the product table. And figure, what is it? 713 and 712. So let's look at figure 712. Has us using the OR clause. So we say give us where the vendor code is this or the vendor code is that. And when we run this guy, that's the result we get, because we used the OR clause. If we do an AND clause, we get a different result set. So here you can see we said we want where the end date is greater than the 15th and January 15th, 2014, and the price is less than 50. And when we run that, everything we get meets those two criteria. Questions? Pretty straightforward. Hopefully it is. You can use what? And and ORs together. That's 714. Here we're saying we want the date greater than the 15th, the product price less than 50, or if the, regardless of those two, if it's this code. Now, here's where the parentheses become important. You want to make sure we're saying let's evaluate these two or evaluate this thing. So you got to be careful with the parentheses. Otherwise, you might evaluate part of this and then these two together. But in this case, we're doing these two, and then we're doing the product code. Just make sure that we always get that product code, no matter if it meets those two. Let's run this and verify that. So indeed, there's that product code, regardless if it met those other two criteria. And I keep switching between SQL view and the graphical view. The graphical view, some people would say it's easier. Some people, who, like myself, who've done a lot of SQL, say, I guess I can see that we're saying we want this, this, or this. And these two being on the same line mean that it's an AND. This one being on a separate line means it's an OR. But I actually prefer to see the SQL, so I know exactly what's going on. Either way. All right. There's a lot of special operators in SQL. There's a between, an is null, a like, an in, exists, and you can see what each one of them does. There's some advanced data definition commands, the alter table to change existing table structures. You can add columns, you can modify existing columns, you can drop, get rid of a column. You can change columns data type with the alter command. I mentioned that earlier. You can change the column's data characteristics. Maybe make it from a string to an integer. Though that kind of a string to an integer probably wouldn't work, right? If it's got existing data, but an integer to a string would be okay. So you can use alter and add. You don't want to do not null for new columns in existing tables. I think I mentioned this in one of the classes before, because there's already existing rows. So if you say not null, that's not gonna fly. You have to allow null when you add a column to an existing table, or if it's going to be not null, you have to supply a default value. Drop in a column, you can use alter and drop, and there are sometimes restrictions on that. Advanced data updates. The update command only updates data in existing rows. If there's a relationship established, you can assign values to the appropriate slots. Arithmetic operators are useful during your data updates. In Oracle, there's a rollback command which can undo changes by the last two update statements. That's special with Oracle. We talked about SQL copying parts of selected data columns using the insert into, so we talked about this a little bit already. The alter table command is used for adding primary and foreign key constraints. And again, all this, while it's great to know the syntax, if you're using SQL, it's easy to go into an existing one, design the table, say we're going to add an index, or maybe a check constraint. Maybe this one's got to be, I don't know. Here we're saying it's got to be something. But when I close this, oops, let's add something else. Let's add, I know. Let's just add an index. Again, running the script gives me, the generate script in SQL gives me the code I would use, so I don't have to know to do it myself. All right. We talked about deleting tables already, using the drop table and the difference between a drop table and a delete table. Drop table removes the table. Delete table removes the rows from the table. There's some other select query keywords. We can do things like counts, min and max values, average. Let's look at some examples of that. So we jump back out here to, let's go to our access for a second. See if we got some, here's where we're doing a count. Let's look at the SQL of that. We can say, hey, I'm using the count function, and we just wrap that around a column. And now, instead of getting all the P codes, so before, well, let's run this. We get the count, so it looks like it's 5. But if we didn't have the count there, and run that, we get each individual one. And indeed, it is 5 rows. But by putting the count on that, we get the count. Now I could do average. I forget in Access what it is. Aver, we'll see. So I'm going to cheat once this comes back. Go to my GUI. What do we want? Average. Isn't that what I had in the beginning? Oh. No, it doesn't want to do an average of product. Oh, right, because that's not an integer. You can't average. It's a character. I can't average a character, so I can count them, sure. But to do an average, it's got to be like price would make more sense to do an average, right? So here I could say, let's do the average price. There we go. That makes more sense. And run that. So it's saying, hey, I didn't have anything selected to show. Now, so I checked it off. Now we're going to see it. Uh-oh. Let's get rid of that guy. We just want to see average price. There we go. So the average price looks like 56. If we go back and we get rid of the average part, we'll see all the prices. And I guess 56 makes sense if you just kind of eyeball that. So a bunch of different functions. Average, min, max, count. Some of them make sense depending on the data type. You can't do an average of a string, but you can certainly do an average of a money or an integer. There's an order by clause that you can use in your select statements. You want a certain order. So if we jump back here and we say, hey, we want all the P codes sorted by P codes. Now it's going to holler at me and saying, hey, you want the average price. Let's turn off grouping. Let's just show P codes ordered by. So they're sorted, right? I don't have to order ascending. I can order descending. And if I look at the SQL, you'll notice it adds the D. So the default is ascending. You can specify ascending, but if I don't specify ascending, then it assumes ascending. So you rarely see that. Generally, you either see that or you'll see, oh, I want this opposite. What else? Oh, you can sort by multiple columns. So I can sort by column code, and then, or in this case, P code, and then if I wanted to sort by the price as well, I could put that in there as a separate one. And I can say descending, descending, or descending, ascending, or descending, ascending there, or maybe this one's ascending and this one's descending. So you can mix and match the, I want this one sorted by one way and this one sorted by another way. Make sense? So here I've got it sorted too. Now you would only see the difference if we had some duplicates, and then you would see the duplicates sorted on the second level. Alrighty, what else? Distinct keyword. If we want just unique values, I can use the distinct statement. So I come back into my SQL for a second and say, you know what? Let's run this guy. And it looks like everything's distinct. We need some duplicates. Let's see if we can find some duplicates. Let's actually go back to SQL for a second and close this for a second. What I'm going to do is I'm going to create some duplicates. So let's do this. Let's go over to our Smart Chart database and do a new query. And we're going to say select into Academy Archive. From Academy. I left out what? I want to select all columns. Oh, I'm not trying to create one, right? So I want to do the insert. There we go. I've already got it. So insert into what? Select star. Already existing, so we don't need to create it. There we go. Run that a couple times. I'm creating duplicates. So now when I select from Academy Archive, What am I selecting? Everything. Look at all the duplicates. So if we wanted to eliminate duplicates, I could select distinct. So now instead of getting 21 rows, I only get 3 rows. Because it says, hey, if any row is duplicated, distinct removes the duplicate rows. And that's a real quick and dirty way of saying, hey, I know I've got bad data, I've got some duplicate data, but just show me those that are, distinct. What else? Some of the basic SQL aggregate functions. We talked about count and average. There's also min, max, sum. Grouping data. So grouping data, and we did a little bit of this already, but we can actually group data either in Access or SQL. We can say, hey, I want to select everything from the Academy archive. And get rid of that up there just to clarify. Now let's group by Academy ID. But when I group, I can't just say, give me everything. I have to say what kind of things, let me see the Academy ID that I'm grouping by. It makes sense. And then typically, so again, this kind of works like distinct because I'm saying just show me, I'm going to group all my rows. So typically when you do a group by, you usually want to count. In this case, I'm going to just count how many times I have ones, how many times I have twos, how many times I have threes. And I don't have to group by ID. I could group by name. Same kind of thing. And that's used a lot in reporting. Give me a count of how many bread makers I have, how many comic books I have, how many connections I have, and the totals. What else with grouping? The having clause. The having is an extension of the group by, and what that does, it's basically a where clause that's applied to the output of the group by. So, what if I said I only want to see records where the count is greater than 5? I can say group by that where the count is greater than 5. I'm sorry, having. Having. Right? So now I only see where, so let's actually fix this real quick. Let's go to our Academy archive and delete all my bread makers, or maybe some of my bread makers, so that we only have maybe, we'll delete that one. Let's do this. We'll do it. We won't use the GUI. Why are we using the GUI? Delete from Academy archive. Where bread makers is equal to, where the Academy ID is equal to 3. So that's going to delete all my bread makers. But I don't want to delete them all. Let's go back and look at this one more time. I'm going to update a couple of them. Oh, look at this error message. It's hollering that it doesn't know which row to update because I don't have a primary key. I mentioned this in the beginning. You should avoid not having primary keys. And here I've created an archive with no primary key. And when I go to update this row, it says, oh, but there's 7 other rows that are the same. I really don't know which row you want me to update. So the answer is, how do I fix this? I need a primary key. I need that surrogate key that we talked about. So let's go into design and let's call this just ID. And we'll make that an integer, and we won't allow it to be null, and we'll make it the primary key, and we're going to make it auto increment. And we'll save that. Now when we close that, this I got to refresh this. So let's close that. Exit. Cancel my update. And now when I edit this guy, because it now has a primary key, I can make changes. See, there's the ID. I can make that a 6 and make maybe this one a 6. Maybe I'll do one more 6. And the reason I couldn't do it before, it couldn't distinguish the duplicate rows. Now it has a primary key. It's able to distinguish the duplicate rows. And now I can just delete the ones that have a 3 left. If I type in the right column name. So now if I say give me everything, I only have 3 bread makers, but 7 comic books and 7 connections. I say, show me the ones where only I have 5 or more, bread makers doesn't show up. The having works as a where clause that applies to the grouped result. Make sense? I can't use where here because this is a grouping. Where, if I wasn't doing a group by, I could do a where against the different, individual values. But when I group them and I want to apply a where to the grouping, I have to use the having statement. All right, let's wrap this guy up. Joining tables. This is when we want data from more than one table. We can use the join. In the form clause, we list the different tables we want to join. We can use the alias to help us join those tables. You can even join a table to itself, and that's called a recursive join. So let me give you a quick example of those two. So if I want to say show me everything that's been archived, I can say show me everything from the Archive Academy, Academy Archive, and I'm going to join on the Academy where, or on, and I'm going to call this AA to help me out, use an alias. And here we'll call this one A, and I'm going to say on A.Academy ID equal to AA.Academy ID. And get rid of all this other stuff. So what I'm saying is, show me everything that's been archived. So let's run this. And because I copied everything, it's all there. But what if I had a row? What if a new row came in here? Called Soda Pop. Well, that hasn't been archived yet. So now when I run this guy, Soda Pop doesn't show up because I'm joining the Academy table. Now, if I just say select star from Academy, I'll see all 4 rows. But when I join on the Academy Archive, I don't see that 4th row. It's not in the set of the 2 tables when we combine them. Does that make sense? So joining the tables combined, at least with an equal to. Now what I could do, suppose I was looking for something that hadn't been yet archived, I could say join these 2. What I would have to do in this case is I'd have to do a right join because I want everything from Academy that doesn't match here. So I'm going to say right join. I want everything here where the Academy ID is equal to that, where this guy is null. I think that's right. Let's give that a shot. So now you can see there's that 4th where we're saying, hey, that guy hasn't been archived. And it looks like that guy hasn't been archived either, right? Because we updated, we got rid of all the 3s. So there's 2 records that exist in the Academy table but don't exist in the archive table. So they haven't been archived. And the way I did that was joining on the 2 IDs, but saying I only want to see where they're not in the Academy, in this case, the Academy archive table. Does that make sense? Very useful query when you're trying to see, what data is missing. You can use, and I did a right join, but I could have made this a left join. If I just change this, move this up here, and move this down here. Same thing. Typically this is what you would see. You would see the table that you want all the data from left joined to the table that you're looking for the missing data. That's typically how people write it. All right, so that was the completion of the intro to SQL. Next week we'll do the advanced SQL, Chapter 8. If you have any questions, shoot me an email, let me know. While you're shooting me an email, feel free to let me know what you think of this format. If you like the recorded lecture, it does give you the capability to go back and at your own pace, rewind and things like that. I think it might be, I'm happy to do more of these if you guys are interested in that. I'm going to put up another recording shortly that will be some of the homework problems worked out. So that'll give you an idea of, if you're stuck on the homework, how to get started with that. So again, thanks for watching. Hopefully you'll enjoy it. Let me know with any questions. I'll see you in class next week. Thanks.